Hey guys, welcome to chapter 4. So, we're out of chapter 17, which was one of our big market failure chapters. And now we're going back to like classic mainstream stuff. So, this chapter is one of the more mathematically rigorous chapters in the book. I think this one and chapter 6 and then chapter 11 are probably the biggest ones. Okay, so this is one of the big ones. After this one, 6 isn't that bad. They basically use all the same math. So you'll notice our playlist is loaded down with lots of material to help you. Okay, there are lots of videos. And so in this mini lecture, I'm not going to do the math. What I'm going to do instead is I'm going to explain why we're doing all that math. And here's the thing. So far, I said, hey, economics, we study human behavior. Hey, look, here's a supply and demand graph. Study human behavior. But where does the graph come from? Like, who made that up and how do they justify it? Well, today we will introduce the theoretical foundation for the demand curve. We're going to use a new model, which if you're a math nerd, you've probably seen this before. It's just a constrained optimization framework. And if you're not a math nerd, this is going to be new. But anyway, we're building the brain, not a literal brain, a mathematical model of a brain. Okay. And so there's like a few things that they like require the brain to do in this. For this chapter, we're just assuming that we're making a choice between two goods and how much of each do we want to buy given our limited budget constraint. Okay, so this is like a classic, hey, I'm at the store, I have limited money, what should I get? Or, tonight I have a limited amount of time. Do I want to spend the time at the bar with my friends or studying? And if both, how much of each? I don't know. Something like that. Like limited resources, you have to allocate it between two options. It's not hard to take this framework and expand it to many, many dimensions, much more than two. But two gets the message across. So that's all we're going to do. So we got two goods. Now, assumptions we put in this brain. We are going to treat our people as utility maximizers. What's utility? It's a thing we make up that measures our satisfaction from consuming the goods. So this utility function, u of xy, or u of x1, x2, depending on the book, that's the brain. The utility function measures our mathematical approximation of a brain. The utility function says how happy we get based on what we consume. And then our goal is going to be to maximize that happiness. The problem is going to be there's a budget constraint and the two goods cost different prices. And so finding the exact mix of the two goods might be difficult. All right, so a couple of assumptions in our standard utility function. One is it's increasing, or at least not decreasing, but usually it's increasing with both goods. I would rather have one of each good than zero. I'd rather have one of one and two of the other than one of each. I'd rather have two of each than one and two. Like if you add to either one, it should increase utility. Another thing is we have something called diminishing returns, which means the first unit consumed gives us more utility than the next unit consumed. Imagine having a slice of pizza. The first slice is almost always better than the second slice. Maybe you can think of some crazy counterexample to that, but it's pretty true in most situations. Most things have diminishing marginal utility. Marginal utility is the utility you get from the next unit of the good. And if you say it's diminishing, that means each good adds less new utility. By the way, if you add all the marginal utilities from everything consumed, you get the total utility, but whatever. So this is where I strongly recommend you check out the videos before we go into the next part of this lecture. At least the one that has a big like 3D graph picture in it and says, where do indifference curves come from? That's important. Do that before you read the book. The book won't make very much sense. That video is important. I mean, if you're like a genius, great. Or if you don't really care about learning this stuff, great. But I think that video really helps the book make sense. It's one of my favorites I've ever made, actually. So I'm going to assume you've read it or watched it. So we've got our brain. We've got this utility function, which looks like that big mountain. And we take the slices of it, each slice being a different level of happiness or utility, I guess. And we try to get to the highest level possible within our budget. And that involves finding that perfect tangency condition. You see pictures of them in your book. You see a cool version of it in 3D in my video. But that tangency condition is where utility is maximized. That's because it shows you where you get the highest utility that is still touching your budget. So that's the goal of all of this. So there's going to be a lot of math leading to what I just said. But finding that tangency condition and the pair of goods that leads to it is how our economic model builds the choices of the two goods. Now, from there, there's going to be more you can do. Okay. We skip chapter 5 because we have a limited time this semester. But basically chapter 5 expands on this and shows like if you're shifting the budget constraints around, you can change the price. And when you lower the price, you substitute towards more of the good because the tangency condition moves. And it basically gives you the law of demand, where price goes up, quantity goes down. And if price goes down, quantity goes up. And that becomes like this foundation for the demand curve. It's the theoretical like explanation of why it should exist. Let's see. Don't forget out some of the special cases, corner solutions and such. I made some cool videos about those as well, especially like goods and bads. There are bads. I always talk about goods, but there are bads also. There are things that you will pay to get rid of. One of mine is the garbage and the recycling and my yard waste. I pay money to have someone come and take those from me. Those are bads, right? Yeah, so check out the videos, work your way through. If you start to get lost in the math, one, I give lots of help. 2, we have the discussion forums. Use them. But also, keep in mind what we're doing. We're just trying to model how someone chooses between two goods and how much of each they want. And the gist of it, like the ultimate, like what it all comes down to, you're going to see this equation in there that says MUX over PX equals MUY over PY. Those MUXs and MUYs are marginal utilities. Those P's are prices. Just like, let me turn my light back on. So MUX over PX is like marginal utility per dollar. It's a bang for the buck kind of thing. And if you ever have a pair of X and Y, where you get more bang for the buck from X than you're getting from Y, so if MUX over PX is greater than MUY over PY, well, then you should have bought more X and less Y, because you're getting more utility from X than from Y. Right? So there's going to be a lot of stuff there about the marginal rate of substitution and stuff like that. But when you get stuck in all that math, all we're really trying to say is, if you get a better bang for your buck from good X, buy more of X. If you get a better bang for your buck from good Y, buy more of Y. How will you know you've completely optimized? The bang for the buck will be equivalent. MUX over PX equals MUY over PY. Because by then you will have always purchased the one that gives the better result. So yeah, I think that's about it. Keep in touch, my friends. Send me emails if you need them. But the default setting, go to the discussion forums. I think there's going to be a lot of you there this week. At least I hope so. Enjoy learning about the theoretical underpinnings of the economic brain, my friends. Good luck. Dang it, wrong computer.